Now, in this video, I'm basically gonna be doing a partial integration, or like when you just decompose the denominator. The method I'm gonna use is called partial fraction decomposition. So the whole thing is just to like reduce the denominator to such that we can be able to integrate it. So the first thing is like to check if you can be able to like factor the denominator, this one, which it can be factored. So now if you check this is the degree 2. If you check x squared minus 1, this is just a polynomial of degree 2. If you look at the function x squared minus 1, that's just a polynomial of degree 2. So what I'm going to do is like I'm going to multiply by 2 on both numerator and the denominator, because that's just a polynomial of degree 2. So now when I do this, I have to like write down the factors of the denominator. If it can be factored, then you have to like write those factors. So I can just say it's x plus 1 and x minus 1. If you factorize x squared minus 1, you're gonna get the factors to be this one. So that's basically simple, really. Now you have to like correspond the denominator. I mean, we're basically trying to like split this so that the degree will be reduced at least by 1. So now what I'm gonna do is you're gonna copy x plus 1, you're gonna copy that, and now because that's this factor now, so you remember in the denominator you'll have 2 into x plus 1 and then multiplied by x minus 1, dx of that. Now if you keep in mind, notice that here you only have like 2, but now here you have x plus 1. And you can also like remember, here we don't have x, here we don't have x, so that means that you'll have to like subtract x again, because if I say minus x like this, the x and minus x will simply reduce to 0. But now you notice that you have 1, and 2 minus 1, that's going to be positive 1, so that's just going to be something like this. So the 2 is just simply expressed as this now. X plus 1 minus x plus 1, it's still 2 if you check it out, because the x and minus x will basically cancel. So that's the whole point of like using this process to like reduce the degree of the denominator. Now if you proceed, you're gonna have x plus 1, you split the fraction. Now you're gonna have x plus 1 divided by 2 into x plus 1 into x minus 1. Now I'm gonna like take this negative sign. Now negative into negative into negative is going to be positive, so you have positive x, and positive into negative is going to be negative, so you have x minus 1. Now you copy the denominator as it is, x plus 1 and x minus 1, and it's basically something like this, dx of that. Now notice that this x plus 1 will cancel this x plus 1, and then you're just gonna basically have the integral of 1 over 2 into x minus 1. Now you have a negative sign here, so you're gonna have a negative into, now notice that, let me copy this. I'm going to split the integral so I can basically express it like this. So now notice that here the x minus 1 and the x minus 1 will cancel. So you're basically going to have 1 over 2 into x plus 1. So now you can simply evaluate this integral. You can just like on this part of the integral, you can just basically take the 2 outside and let u equals x minus 1, then du is equals to dx. And now basically now, or what I'm going to do is like you can take the half outside. Notice that you have a 2 in the denominator, you can take it outside, so you're just going to have half, and then now you're going to have 1 over, now x minus 1, it's u, and now dx is the same as du, so I'm just going to basically have 1 over u du. Now on this other integral, I'm basically going to let k equals x plus 1. So I can let k equals x plus 1, then dk will be equals to dx. Then now, so I can take also the half outside because I have 2 in the denominator, so you can take the half outside. So you're just going to basically have 1 over k dk. So now what's the integral of 1 over u? The integral of 1 over u is basically going to be ln the absolute value of u, and now you have minus half. Now what's the integral of 1 over k? It's just going to be ln the absolute value of k. And now you're going to add a constant there. Now notice that from now you can factor by half, and you're going to have half into ln the absolute value of u minus ln the absolute value of k, so plus a constant now. So basically you're going to have something like this now. So now when you have this, when you have ln something minus ln the other term, ln one term minus ln the other term, you can basically divide that. So you're gonna have ln the absolute value of u divided by k plus a constant. So that integral is gonna be because basically what I'm doing is like I'm using the natural log formulae, the logarithmic formulae. You can look into those, or I'm gonna make a video about those. Now keep in mind that now you made a substitution. Now it's time to substitute back. What's u? U equals x minus 1. And what's k? K is equals to x plus 1. So now that means that you're gonna have ln the absolute value of x minus 1 divided by x plus 1 plus a constant. So that's basically how you can like work that integral out. The integral of this will just be this. So you use partial integration to just reduce the degree. Notice that I reduced the degree from 2 to just 1 because like you can basically see I just reduced it to a lesser degree. I reduced that degree by 1. So that's the whole point of like using partial integration. So if you master this trick, then integration should be able to like appear simple to you, because like if you are able to like master this process, then you can basically integrate almost. See if you can yeah, x square over x square minus 1. I wanted to put a positive here, but let's deal with a negative for now. So now how will you be able to like integrate it? You can just pause the video and see if you can use the method I just showed you to like decompose this. So what I'm gonna do, just pause the video and try it. Okay, I'll be waiting. Okay, fine. It's fine if you think you cannot do it. So let me just show you what I'm going to do. So you map the numerator and the denominator. So I'll just have like x squared minus 1 plus 1. Notice that this is 0. So you basically didn't change anything in the numerator. So you have this integral. So now notice that you're going to split the fraction into x squared minus 1 over x squared minus 1 plus, you take the sign, which is positive, dx, plus the integral of 1 over x squared minus 1 dx. Then you use partial integration in order to like evaluate this integral. So you basically realize that it's simple to like evaluate these integrals. You just like manipulate it in order to like reduce, in order to be able to reduce it to a method you know you can be able to like integrate. I just showed you the integral of this, so you should be able to like integrate this by now. So partial integration can get a little bit complicated. So try like working out the simple problems I give you, so they serve as basics in order to like work out even complicated integrals. Okay, so try to like see if you can like be able to integrate 1 over x squared. Let me not use let's say x squared. Let's see, or should I say x cubed? I'm trying to avoid cube because it's gonna be a little bit complicated if I involve cube, but whatever. So x cubed minus 1 dx. Yeah, so this is gonna be it's gonna be like you have to be patient with me on this one. So in fact it's gonna be so long like it's gonna defeat the whole purpose of making this video. So I worked it out privately, so I'm just gonna show you the thing and then explain what's happening. So yeah, this is how you evaluate that. So basically you multiply, like I said, you multiply by that degree. Here's degree 3, so you multiply both numerator and the denominator by 3, and then you factor x cubed minus 1, which is gonna basically look like this. So when it looks like this, you copy this as it is, x squared plus x plus 1. Now you map that with the numerator here. Notice that you don't have x squared in the numerator, so you're just gonna subtract x squared. Notice that you don't have x in the numerator, so you basically have to subtract this x. You have to subtract it. And notice that here you have 1 and here you have 3. That means you'll have to add 2. So if you look at this, it corresponds with this, because x squared will cancel x squared and x will cancel negative x, and 1 plus 2 will be this 3. So now you split the fraction into x squared plus x plus 1 divided by the whole denominator. You take the sign negative, you take the sign which is negative and you put it here. Why didn't I show all steps here? So when you take this negative here, you're gonna have x squared plus x minus 2, because negative into negative is going to be positive, and negative into negative is positive, and positive into negative is going to be positive. And then this term factorizes to this term factorizes to x minus 1 into x plus 2. So now you copy the denominator as it is. Now notice that here x squared plus x plus 1 basically cancels with the denominator here, and then you'll be left with 1 over 3 into x minus 1. And now here x minus 1 will cancel with x minus 1, so you'll have x plus 2 into 3 into x squared plus x plus 1. So now you split the integral. Now when you split that integral, you can basically take the 3 outside and it's in the denominator, so you're gonna have 1/3 of that. So you have 1/3 of that. Now notice that here we can do we have to like correspond this x plus 2 and the denominator, because if we assume that the integral involves ln, we'll have to have 2x plus 1, because the derivative of this will be 2x plus 1. Now what I'm going to do is like I'm going to multiply both numerator and the denominator by 2. So now 3 by 2, that's going to be 6, and then 2 times x, that's going to be 2x, and 2 by 2, that's going to be 4. So basically you're going to have something like this. Now you're going to basically have something like this. So now you're gonna break it down. You're gonna have 2x plus 1, which I talked about, which is the ln, how you're gonna get the ln. Now since you have 2x plus 1, 4 and 1, that means I'm short of 3, so I'm basically gonna have to add 3. But notice that you have negative outside, and negative into positive is gonna be this negative. That's why you see this negative here. So you remain with 3 on the side, so you have 3 over 6 into x squared plus x plus 1. And on this side we basically talk that it's ln. If you work that out, you're gonna get ln, because you're gonna make a substitution. Substitute x squared plus x plus 1 equals u, and then you're gonna evaluate this integral. You're gonna have 1 over 6 ln x squared plus x plus 1. The reason I didn't put absolute values is because this is always positive. And now if you work this integral here, you're gonna have ln the absolute value of x minus 1. Don't forget the 1/3 out here. So now this 1 over 6 is the same as 1 over 3 times 1 over 2, and you can take the 1 over 2 back into the ln, and then you're gonna have the square root of this. Forget this for a second. Focus on this simple parts first. Now ln something, you're gonna factor by 1 over 3, and when you factor by that, you're gonna have ln the absolute value of x minus 1 minus ln this, and when you subtract ln c, you're basically gonna divide the terms inside. So the terms inside divide, so you're going to have the absolute value of x minus 1 divided by the square root of x squared plus x plus 1. So now you have 1/3 of that. Now focus on this part now. Now this one cannot be, you cannot decompose it now. So if we cannot decompose it, we're going to assume that, remember when you derivate arctan, you have 1 over 1 plus x squared, which is the degree that we have here. So we're going to correspond this with tan. We're going to assume that the integral of this is arctan, because we basically can correspond this denominator here. We can factor that. So what I'm going to do is I'm going to factor by 4/3. I'm going to multiply both numerator and the denominator by 4/3, and then the 3 and the 3 will cancel, so you're just gonna basically have 4 in the numerator like this. And now I took the 1/6 outside, the 6 outside like this. Now that you have 4 in the numerator, you have 4/3. You just multiply everything here. You have 4/3 x squared, and then you have 4 over 3 by x, which is just 4 over 3x. Now 4 over 3 by 1 is 4 over 3, which you're gonna split into 1 over 3 plus 1. Now notice that this term itself, it factors to this. You're gonna factor it to 2 over root 3x plus 1 over root 3 square, and then you're gonna add 1 there. If you expand this, you will see that it gets back to this one. So now you're gonna make I don't know how you're gonna evaluate this. You can like make a substitution, u equals 2 over root 3x plus 1 over root 3. That's the, if you don't understand what I'm about to show you below here, you can make that substitution here, so you can be able to work that integral out. So what I'm gonna do is now I derivate what's inside. The derivative of what's inside is gonna be 2 over root 3. What's inside the square, the derivative is 2 over root 3. But now I have to account that basically gonna have to multiply by its reciprocal, so the whole of this becomes 1. So that means you don't really change anything there. So you have 2/3. Now 4 and 3 over root 3 over 2, you take them outside, so you have 2 over root 3 into this. So when you integrate this, you're basically gonna have arctan, what's inside here. because the derivative of what's inside is in the numerator, so you can basically have arctan of this term. Now 4 root 3 and 6 by 2. Notice that 4 is the same as 2 by 2. 4 is the same as 2 by 2. One of the 2's will cancel this, and now 6 is the same as 3 by 2, and then the remaining 2 in the numerator will cancel the 2 in the 6, so you're not gonna have root 3 over 3 acts on this. So that's basically the integral of 1 1 over x cubed minus 1. So that's the integral. That's why I was like, it's gonna be a long process. That's why I just worked it out so I can just explain it on the video. If I had to like work this out, it was gonna take a long time, because obviously writing and working something out is not the same thing. So now hopefully I think like you'll find decomposition quite useful, because it simplifies, it reduces this coefficient here. The degree, it reduces the degree of that integral, so it's easier to like work out. So that's decomposition, people. So hopefully just practice how to apply it and where to apply it. Don't just apply decomposition everywhere. So there are places where you have to like apply it. So now you have tricks to apply on integration. So you can basically like use partial integration, use substitution or trigonometric substitution, or you can use integration by parts. So that's how you can like integrate. So if you mastered all 4 steps of like integrate